But today also we are going to solve some sums in quadratic equation, right? Right. So the first question is, prove that 1 divided by 3x plus 1 plus 1 by x plus 1 minus 1 divided by 3x plus 1 multiplied by x plus 1 does not lies between 1 and 4 if x belongs to a real number. Okay? Okay. So this sum is much more similar to the sum that we solved in a previous class, but the slight difference is, see, we have to going to prove here, not we are going to find the range. We are going to prove this x does not lies between 1 and 4. Right? Right. Shall we start solving? Yes. Solution. Right? Right. Okay. So what's the first thing? While solving the sum, we are going to assume let y equals, right, the entire term. So what is the term? 1 divided by 3x plus 1 plus 1 divided by x plus 1 minus 1 divided by 3x plus 1 multiplied by x plus 1. Right? Right. So I am going to take this as a common LCM. So common denominator, right? Right. So see, here, okay. See the denominators of three terms. Here 3x plus 1, here x plus 1. This term contains 3x plus 1 and x plus 1. So I can take this 3x plus 1 multiplied by x plus 1. See, this term, compare this denominator and this entire denominator. See here 3x plus 1. Here also 3x plus 1. But what we didn't have here? X plus 1. So I can cross multiply this x plus 1. Okay? Okay. Now see here what we have, x plus 1 alone. What we didn't have here? 3x plus 1. So I can multiply with this numerator. Right? So 1 plus 3x plus 1. Okay. See here, we have both the terms and this also contains both the terms. So the numerator remains same. Right? We simply do the LCM in a simple format. Right? Right. Whenever we have two different terms in an entire term, we will take the entire term and we will find the missing part and we will multiply it with the numerator. Here we have numerator as 1 in both the conditions. So we simply put it in numerator, right? Right. Shall we simplify this? Yes. Which is equals. So here it is positive x, here it is positive 3x. So it will become 4x. Right? Right. Here it is 1, here it is 1. So 1 plus 1, 2. 2 minus 1 again, plus 1 divided by, we can multiply this, right? Right. So I am going to multiply this term by 3x. So 3x squared plus 3x. Now I am going to multiply it by 1. So it will become x plus 1. Right? We can again simplify this. So it will become 4x plus 1 divided by 3x squared. See here on 3x, here on x. So it will become 4x plus 1. Okay? Okay. So I will give you 1 minute so that you can copy this and we will move to the next part of the sum. Okay? Okay. Okay, I hope you all copied this, Shalera. Yes. Okay, till now what we find? Y equals what we find? 4x plus 1 divided by 3x squared plus 4x plus 1. Clear? This is what we find. Okay. So now what I am going to do is I am going to take this denominator to the left hand side. See, it is in division. When it comes to this side, it will become multiplication. So this term becomes y multiplied by 3x squared plus 4x plus 1, which is equals 4x plus 1. Now I am going to take this y inside this term. So it will become 3yx squared plus 4yx plus y. Right? Right. I am going to take these two terms to the left hand side of the equation. See, they are an addition. When it comes to this side, it will become subtraction. So minus 4x minus 1 equals 0. See, we are again going to simplify this. Is there any other x squared term? No. So it will remain 3y squared. See, here there are two x terms. So I am going to take x as common. So what will remain? 4y here minus 4 plus. So what are the terms we remaining have? Y and minus 1. So y minus 1, which is equal 0. Right? Right. So I am going to compare the above equation with ax squared plus bx plus c equals 0. Right? Right. See here. A is the coefficient of x squared. Here what is the coefficient of x squared? 3y. So I can write a equals 3y. Similarly, b is the coefficient of x. Who is the coefficient of x here? 4y minus 4. So I can write b equals 4y minus 4. Right? Right. See the constant here. Who is the constant here? So in this equation, the constant is y minus 1. Right? Right. So what we did so far? We take the equation and equated this to y and simplified the equation and compared it with ax squared plus bx plus c. While comparing this, we get the value of a, b and c. This is what we did so far. So I will give you 1 minute. You can copy this and we will move to the next sum. Okay? Sorry, next part of the sum. I hope you all write the sum. Shall I wrap? Yes. So what we find? We find A equals 3y and B equals 4y minus 4 and C equals y minus 1. So up to this we find, right? Right. So see the question. What we are provided with? We are provided with the information at the end. What is that? So here x belongs to real number, right? Right. So if x is real, since from the question x is real, we can say that del must be greater than or equal 0. Right? If del must be greater than or equal 0, then b squared minus 4ac must be greater than or equal 0. Right? Right. So we can say, no, we know the value of a, b and c. We can easily substitute the value of a, b and c. Okay? Okay. So what is b? 4y minus 4 the whole square minus 4. What is a? 3y. What is c? Y minus 1 greater than or equal 0. Clear? Clear. See, it is in the format of a minus b the whole square. Right? A minus b the whole square, which is equals a squared plus b squared minus 2ab. So what we have? In place of a, I have 4y. In place of b, I have 4. Right? What is a squared? 4 y the whole square. 4 squared is 16, y squared is y squared. Plus, what is 4 squared? 16 minus 2 multiplied by 4y multiplied by 4. So, which is equals 16y squared plus 16 minus 4 4s are 16, 16 2s are 32. So, 32y. Okay. So, in place of this, I can write this one. Okay. Right? We are just expanding this one. Right? Right. So, in place of 4y minus 4, I am writing 16y squared plus 16 minus 32y. Okay? Okay. So, see here. I am going to keep 4 as it is. And now I am multiplying 3y with this. So, 3y into y, 3y squared minus 1 into 3y, 3y must be greater than or equal 0. See, I am going to keep these terms as it is. 16y squared plus 16 minus 32y minus, sorry, yes. I am going to take this minus 4 inside this. So, it will become minus 12y squared minus into minus plus 12y greater than or equal 0. Okay? Okay. Now we can simplify this, right? See, here we have plus 16y squared minus 12y squared. 16 minus 12 is 4y squared. Okay? See, now I am going to solve for y. So here it is 30 minus 32y. Here it is plus 12y. Minus 12 plus 20. Sorry. Minus 32 plus 12. What we get? Minus 20. Super. So minus 20y. So who is left out? Yes, that's a constant which is plus 16. So I can write plus 16 greater than or equal 0. Okay. So I will give you 1 minute so that you can copy this and we will move to the next part of the sum. See what we did here. We already find the value of A, B and C. As in the question itself, we are provided with x belongs to real. If x is real, then del must be greater than or equal 0. So if del must be greater than or equal 0 means b squared minus 4ac must also greater than or equal 0. So we know the value of b, a and c. So we substitute all the values here and we simplify this. Till now we get 4y squared minus 20y plus 16 must be greater than or equal 0. I hope you all copied this sum. Shall we move? Yes. So what we get is 4y squared minus 20y plus 16 must be greater than or equal 0. This is what we get, right? Right. Now, see, in all the terms are lies in multiples of 4, right? So, now I am going to take 4 as common. So, when we take 4 as common, it will become y squared. So, when we take 4 from 20, so 5 multiplied by 4 is 20. So, it will become 5y. And 16 is 4 4 so 16, so it will become 4 greater than or equal 0. Now, we are going to take this 4 this side. So it will become y squared minus 5y plus 4 greater than or equal 0 by 4. 0 by anything is again 0. So we can directly put 0 here. Right? Right. Now what I am going to do is I am going to replace this 5y. Right? So what we have minus 5y. I am going to write minus 5y as minus 4y minus 4y. What is minus 4y minus y? It is minus 5y. So for simplification purpose, I am writing like this. So minus 4y minus 4y minus y plus 4 greater than or equal 0. See, in both the terms we have y is common, right? So I am taking y. So what we have? Y minus 4. In this time I am going to take minus 1 is common. Right? What we will get? Y minus 4 must be greater than or equal 0. So see, in both the terms we have y minus 4. So I am taking this out. Y minus 4 multiplied by y minus 1 greater than or equal 0. Okay? Okay. So we are almost solved the sum. I give you 1 minute so that you can copy this and we will move to the next and final step. Okay? Okay. So I hope you all copied this. Shall we rub and solve? Yes. So what we solved? We solved up to y minus 4 multiplied by y minus 1 must be greater than or equal 0. Clear? Clear. So, okay. So what are we are going to find? We are going to not only find, we are going to prove the y, the given equation does not lies between 1 and 4, right? Right. So for that we can solve it separately. So y minus 1 must be greater than or equal 0 and y must be 4, y minus 4 must be greater than or equal 0. Okay? Okay. So here what we can do? Think if there are any other methods to solve this? Okay. So what I am going to do now is I am going to move this y this side. So it will becomes minus y. Okay. So what we find? Y must be less than 1. See here. I am going to take this to the other side. So what we get? Y must be greater than 4. So what must be the range? So y must belong to minus infinity to 4 union, sorry, minus infinity to what we get? 1. Right? And 4 to infinity. See? See. What we know? We know as 1, sorry, y is less than or equals 1. Right? Right. So, it must be minus infinity to 1. So, what we get here? Y is greater than 4. Right? So, what will greater than or equals 4? So, what are the possibilities? 4 to infinity. Right? So, we find y lies between minus infinity and 1 union 4 and infinity. So, from this what we can find? We find here. We find the range of y. So, what is y? Y is the given expression. So, we can say given expression. Okay, it's clear. Lies between minus 1, infinity and 1, union 4 and infinity. So, what we find? What we have to do? We have to prove what? The expression does not lie between 1 and 4. Here we see the expression lies between minus infinity and 4 and 4 union infinity. So, it does not lie between 1 and 4. So, we can also write given expression. Okay, it's visible. So, given expression does not lie between 1 and 4. Right? Right. So, here The expression lies between minus infinity to 1 and 4 to infinity. It does not lie between 1 and 4, right? Right. This is what we have to prove. So finally we can write hence proved. Okay. So I will give you a minute so that you can copy this and we will move to the next step. Okay. So did anybody have any doubt in this sum? Kindly put your doubt in a chat box so that we can clearly clarify the doubt right now. I hope you are clear with the sum. Shall we move to the next one? Yes. Okay. So the next sum is if x is real, then prove that x divided by x squared minus 5x plus 9 lies between minus 1 by 11 and 1. Right? Right. We are going to solve this sum as like that of a previous sum. So what is the point here? We have to find the range first, and if the range is between minus 1 by 11 and 1, so we can prove that easily, right? Right. Okay, solution. So what is the first step? Super. We have to equate the given equation to y. So let y equals x divided by x squared minus 5x plus 9. Okay? Okay. Now what I am going to do is I am going to take this denominator to the left hand side. So it will becomes y multiplied by x squared minus 5x plus 9, which is equals x. So now what I am going to do? I am going to take the y inside the little expression, right? So it will becomes yx squared minus 5yx plus 9y, which is equals x. So now I'm going to take this x inside this. So it will becomes yx squared minus 5yx plus 9y minus x equals 0. Right? I'm going to simplify this one. So is there any other x squared term? No. So yx squared remains the same. See here there are two x terms. So it will becomes plus minus of 5y minus 1 multiplied by x plus 9y, which is equal 0. Okay? Okay. So I will give you 1 minute so that you can copy this and we will move to the next step. I hope you all copied this diagram. Yes. So what we find? What we find is y x squared plus minus 5y minus y multiplied by x plus 9y equals 0. See, we find up to this, right? Right. So what I am going to do now is we are going to compare this equation with the standard equation. So I am going to compare it with ax squared plus bx plus c equals 0. What is, while we comparing these two, so a is the coefficient of x squared. So who is the coefficient of x squared here? Y. So a equals y. Okay. So while comparing the coefficient of x, so b equals minus 5y minus 1. So c is the constant. So c equals 9y. Okay? Okay. So what's given in the question? So according to the question, x is real. So we can write since x is real, right? We can know that del must be greater than or equal 0. Right? Right. So if del must be greater than or equal 0 means again b squared minus 4ac must also be greater than or equal 0. See, we know the value of a, b, c here. So we can simply substitute here. So minus 5y minus 1 the whole squared minus 4 multiplied by y multiplied by 9y must be greater than or equal 0. Right? Right. So C minus 5y minus 1 the whole square. Right, I am going to expand this. I am going to take a plus b the whole square like this. It will be a squared plus b squared plus 2ab. Okay, it will be not clear. Okay, copy this up to this and we will move to the second step. Right? Right. So I hope you have copied this and we move to the next step. Yes. So the question, oh, I have the question, right? Right, given by 1 by 11 and 1. So what we find up to? We find up to minus 5y minus 1 the whole square minus 4 multiplied by y multiplied by 9y must be greater than or equal 0. Okay? Okay. Once again. So see, it is here in both the terms are in minus. So I am going to compare it with a plus b the whole square, which is equals a squared plus b squared plus 2ab. In I am going to take minus 5y as a and minus 1 as b. Right? Right. Minus 5y the whole square is minus into minus plus. So 5y is 25y squared plus What is b squared? B is minus 1. Minus 1 the whole squared is 1 plus 2 multiplied by a is minus 5y. B is minus 1. So it will become 25y squared plus 1. 5 2s are 10. Here 1 minus, here 1 minus, they will get plus. So plus 10y. Okay. So in place of minus 5y minus 1 the whole square, we can substitute this, right? Sorry. Okay. So we can substitute 25y square plus 1 plus 10y. Okay? Okay. So now I am going to multiply these two. So 9 into y into 9y, 9y square must be greater than or equal 0. So 25y square plus 1 plus 10y. 4 into 9, 36. So 36y square must be greater than or equal 0. So here only one y square term, so 25y square. Here it is plus 10y minus 36y. So it will be minus 26y. Sorry, it's y square, right? See, here it is 25y square. Here it is 36y square. So, sorry, but the 36y square is negative. Here it is positive. So, minus 36 plus 25. What we will get? Yes, we will get minus 11y square plus 10y plus 1 must be greater than or equal 0. Clear? Clear. So, I am going to take minus 1 as common from these things. So it will become 11y squared plus, 11y squared minus 10y minus 1 must be greater than or equal 0. We are going to take this minus 1 this side, so it will become 11y squared minus 10y minus 1 must be greater than or equal 0. So 0 divided by minus 1. Anything by 0 by anything is 0. Okay? Okay. So I will give you half a minute so that you can solve. So I hope you all copied this. Shall we move to the next step? Yes. Okay, up to what we solved? Up to this one we solved, right? Right. Okay. So what we solved? 11y squared minus 10y minus 1 must be greater than or equal 0. Right? Right. So in place of minus 10, what we can write? Okay. We can write 11y squared minus 11y plus 1y minus 1 must be greater than or equal 0. So what is minus 11y plus 1y? It is again 10y, right? So for solving this purpose, we are replacing minus 10y with minus 11y plus 1y. So now I am going to take minus 11 outside this. 11y outside this. So what we will get? Y minus 1. So from both the things we are taking 1 as common. So what we will get? Y minus 1 must be greater than or equal to 0. So see, in both the terms we will have y minus 1. So we are taking y minus 1 as common. So what we will get? 11y plus 1 must be greater than or equal 0. Okay. So now we can equate this separately. Y minus 1 must be greater than or equal 0 and 11y plus 1 must be greater than or equal 0. Okay? Okay. So now, the board is up to this. Okay. So I will give you a minute so that you can copy this and we will solve the final step. Okay. So here I am going to take y to the another side. So it will becomes minus 1 less than or equals minus y. So y get cancelled. So 1 must be greater than or equals y. Okay? I hope you all copied this. I will read up and solve again. Yes. What do you find? Y minus 1 must be greater than or equal 0. Similarly, 11y plus 1 must be greater than or equal 0. Okay? Okay. So see, I am going to take this y to the other side. So minus 1 must be greater than or equals minus y. So 1 must be greater than or equals y. So I can write it like this, right? Right. Y must be less than or equals 1. Okay, to the other side. Okay, 11y. I'm going to take this 1 to the other side, so it will becomes minus 1. So y must be greater than or equals 1 by 11. Okay, so we can write minus 1 by 11 less than or equals y less than or equals 1. Right? From this, we can say y lies between minus 1 by 11 and 1. So, the given expression also, because since for the first step we take, we equate the entire equation to y. So, from this we can say the given expression also lies between minus 1 by 11 and 1. Okay? Okay. What we have to prove? We have to prove is the given equation should be lies between minus 1 by 11 and 1. So we proved this. So we can finally write hence proved. Hence proved. Clear? Clear. So I will give you 1 minute so that you can copy this and we will move to the next sum. I hope you are clear with this one. Shall we move to the next one? Yes, shall I run? Yes. Okay. So see, the question is little bit different. So what is given? If the expression x minus p divided by x squared minus 3x plus 2 takes all the real values for x belongs to natural real numbers, then find p. See, it is find the limits of p, right? Right. Okay. See, we are provided with the expression. In the expression, there is a variable p. We have to find the limit for p, not for the expression, right? Right. To solve this, we are going to do like this sum, much more similar to that of a previous sum. Okay? Okay. Shall we start to solve? Yes. So, solution. As like that of a previous sum, we are going to take this equation equals to y. So y equals x minus p divided by x squared minus 3x plus 2. Now I am going to take the denominator to the left hand side. So it will becomes y multiplied by x squared minus 3x plus 2, which is equals x minus p. So now I am going to take y inside this equation. So it will becomes yx squared minus 3yx plus 2y. Alright? Right. Now what I am going to do is I am going to take this x minus p to the other side. So it will becomes minus x and plus p equals 0. Okay? Okay. So I'm going to simplify this again. There is only one x squared term. So as it is. So plus I'm going to take these two x's common, right? So it will becomes minus 3y minus 1 plus 2y plus p remains the same, which is equal 0. Right? I'm going to compare it with ax squared plus bx plus c equals 0. Right? Right. Who is the coefficient of x squared here? A. So who is the coefficient of x squared here? Y. So a equals y. Similarly, b is the coefficient of x. Here the coefficient of x is minus 3y minus 1. C is the constant. C equals to y plus p. Okay? Okay. So I will give you a minute so that you can copy this and we will move to the next step. Okay, I hope you are clear with this. Shall we move? Yes, before that I will explain this once again. So we are provided with the expression. In this expression, we have a variable p. We are going to find the limits of p. So that we are take the entire equation and equate it to y. And we simplify this and we compare it with ax squared plus bx plus c. And we up to now we find the value of a, b and c. Okay? Okay. So see, in the question itself, we know that x is real, right? Right. Since x is real, del must be greater than or equal 0. If del must be greater than or equal 0 means b squared minus 4ac must be greater than or equal 0. Right? What is the value of b? Minus 3y minus 1 the whole minus 1. So here it is b squared. So whole squared. Minus 4. What is the value of a? Y. What is the value of c? 2y plus p. So these must be greater than or equal 0. Okay? Okay. So now I am going to simplify this one. Right? Right. Okay, so see, in both the terms we have minus. So I'm going to take minus 1 is common. So 3y plus 1 the whole square. So minus, I'm going to take this y inside this. So it will becomes 2y squared plus py must be greater than or equal 0. Again, see, it is minus 1. Minus 1 multiplied by 3y plus 1. So minus 1 the whole squared is plus 1. 3y plus 1 the whole squared is whole squared. 3y plus whole squared. So now I am going to take this 4 minus 4 inside. So it will becomes minus 4 into 2y squared minus 8y squared minus 4py greater than or equal 0. So it is in the format of a plus b the whole squared. So what is the formula for a plus b the whole squared? A squared plus b squared plus 2ab. What is a? 3y. What is a? 3y squared? 9y squared. What is b here? 1. What is b squared? 1 the whole squared is 1. Right? What is the next step? 2ab. So plus 2 multiplied by 1, 2. 2 multiplied by 3y, 6y. Clear? Clear. What we have? Minus 8y squared minus 4py must be greater than or equal to 0. Right? Right. So we have 2y squared terms. 9y squared minus 8y. 9 minus 8 is y. 1, right? So y squared. So we have 2 y terms, right? So I am going to take y as common. So it will become 6 minus p multiplied by y. Okay? Okay. So what is the constant? The constant is 1. So I am going to keep the constant as it is. Must be greater than or equal 0. Okay? Okay. So I will give you a minute so that you can copy this and we will move to the next step. I hope you all copied this. Shall I wrap? Yes. So what we did, since in the question, before this step we found the value of a, b, c. Since in the question we are provided with the value of x is real, so we take x is real means del must be greater than or equal 0. And if del must be greater than or equal 0, we find b squared minus 4ac must also be greater than or equal 0. We already know the value of b, a and c, so we substituted and we simplified up to this. Okay? Okay. Shall I wrap? S. Okay. So what is the last step we find? Y squared plus 6 minus p multiplied. Okay. So it is 6 minus 4p, right? We missed the 4. 6 minus 4p multiplied by y plus 1 must be greater than or equal 0. Right? We missed the 4 in the previous equation. Right? Right. So now I am going to compare it with ay square plus by plus c equals 0. Okay? We are going to compare both the things. Compare. So a must be equals 1 and b must be equals 6 minus 4p and c must be equals 1. Clear? Clear. Since the question takes all values are real, right? So I can take real. Del must be greater than or equal 0. If del is greater than or equal 0, b squared minus 4ac must be greater than or equal 0. So we know the value of b, which is 6 minus 4p whole square minus 4 multiplied by a, which is 1, and c is also 1, right? Right. Must be greater than or equal 0. So it is in the format of a minus b the whole square, which is a squared means 36 plus 16p square minus 48p minus 4 must be greater than or equal 0. Okay? Okay. So I will give you a minute so that you can copy this and we will move to the final step. Okay. Right? Right, shall I wrap? Yes. Okay, what we find? 36 plus 16p squared minus 48p minus 4 must be greater than or equal 0. Right? Right. So I'm going to simplify this. So 16p squared minus 48p plus 36 minus 4 is plus 32 must be greater than or equal 0. So I'm going to take that 16 as common. So it will become p squared minus 3p plus 2 must be greater than or equal 0. So p squared minus 3p plus 2 must be greater than or equals 0 by 16. 0 by anything is 0. So 0. Okay? Okay. To simplify this, I am going to rewrite p square minus 2p minus p plus 2 greater than or equal 0. So I am going to take p as common. So it will become p multiplied by p minus 2. I am going to take minus 1 as common. So p minus 2. So since both the term of p minus 2, I am taking p minus 2 as common. So it will becomes p minus 2 multiplied by p minus 1 less than or equal, greater than or equal 0. Okay? Okay. So I will give you a minute so that you can copy this and we will move to the next step. Fine? Fine. Okay, I hope you copied this diagram. Yes. So what we find? P minus 2 multiplied by p minus 1 must be greater than 0. Right? Right. So we can separate this p minus 2 greater than or equal 0 and p minus 1 greater than or equal 0. Okay? Okay. Fine? Okay, in this time I'm going to keep this minus 2 as it is. I'm going to move p this side. So it will become 2 greater than or equals p. And this side I'm going to move minus 1 to that side. So it will become plus 1. Oh, it's p, right? So while combining this, 1 less than or equals p less than or equals 2. Right? Right. So we can, what we have to find? We have to find the limits of p. Did we find the limits of p? Yes, we find the limits of p. So we can write the limits of p is 1 less than or equal p less than or equals 2. We can also write p belongs to 1 comma 2. Okay? Okay. So what we did in the sum? See, we are provided with the expression. In this expression, there are two variables. So, one is x and one is p. So, what we did? We initially take the entire equation to equals y and we simplified it and we compared it with ax squared plus bx plus c equals 0. And we found the value of a, b, c, and we know all values lies here are real. So del must be greater than or equal 0. So we take that b squared minus 4ac must also be greater than or equal 0. And we found that put and we find another expression, right? That is y squared plus 6 minus 4py plus 1 must be greater than or equal 0. See, again comparing it and we find ABC. Again we take all the values lies here are real. So b squared minus 4ac must also be greater than or equal 0. And we put again the values and we find this equation. And finally simplifying this equation we find the limits of p. I hope you are clear with this sum. Did anybody have any doubt? Kindly put those doubts in the chat box. Okay? Okay. So any doubts? So feel free to clear your doubts so that you can be well versed in everything, right? Right. So if you are not comfortable with unmuting your mics, kindly put your questions on chat box or else type clear in the chat box so I can be clear with you. All guys are clear with the sum. Okay guys, thank you.